Good morning, everybody, and welcome to today's webinar. My name is Richard Broad. I'm a director at the ASBP. I'm really delighted to be hosting today's webinar on building with lime. So this is a bit of an overview of what we'll be covering today. So you'll be finding out more about our new community of practice called the Lime Group. So I'll give a bit of an intro to the group in a minute. So it's an opportunity to get to know our group members. We've got some really interesting case studies showcasing a range of different applications for lime construction products. We've also got a bit more of an in-depth presentation, an introduction to lime products. So we'll be looking at the history of lime, the multiple benefits, the wide range of applications, and how these products can be used with complementary materials such as natural fiber insulation. And then we'll have around 20 minutes for Q&A with our expert speakers. So this is today's program. So I'll shortly hand over to our group members. So they're all going to briefly introduce themselves, and then we'll hand over to Peter at Mike Y for the intro to lime building products presentation. We've got 5 really interesting case studies, and then hopefully some time for Q&A. So I don't want to steal Peter's thunder, but just a very quick intro to lime, and our expert speakers will explain this far better than I can. But just to say that lime refers to quicklime and is made by heating limestone at high temperatures in a kiln. And lime has been used in construction as a binder in mortars and plasters for thousands of years, dating back to the Roman times. So it's generally seen as an ideal solution for conservation, restoration, and heritage projects, but it's equally suited to modern new build development, which you'll see in our case studies a little later. So these are the instructions for the webinar. It's all pretty straightforward. If I could ask you to add any questions to the Q&A and not the chat. You can also upvote and comment on other people's questions, and we'll read out the most popular question first. Please do not use the raise hand option. We won't be keeping an eye on that one. If we've got time, we'll unmute you so you can ask the question yourself. Any technical problems, please write a message to my colleague Larry Tate in the chat, and we are recording today's session. So a very quick intro to the ASBP for those who are not familiar with us. Hopefully you are. So we are the Alliance for Sustainable Building Products. We are a not-for-profit mission-led sustainability organization, and our mission is to transform the built environment to be healthy and low carbon. And we do this by championing demonstrably sustainable building products. And we have a wide range of activities. So we do lots of events and webinars such as this. We lead and partner on research. We create guidance. We're very collaborative. We've got lots of partners and friends across the industry. We seek to influence policy. And we do this through what we call our 6 pillars of sustainable construction, which is our holistic view of sustainability, covering topics such as health and well-being, resource efficiency, etc. And a bit of an intro to our Lime group. So as I say, this is a new group that we're launching today, and it's a community of practice of our members, and they are the leading manufacturers, suppliers, and experts in lime-based construction products. So a big thank you to our members for supporting the group, and it's yeah, a real delight to launch and host today's webinar. And the aims of the group, so if you've been to any of our previous webinars on natural fiber insulation or healthy paints and finishes, it's a similar sort of ethos, and the aim is to work collaboratively to essentially better communicate the benefits of these products. So as I say, we're working on a briefing paper, which is an introduction to lime building products. So that will be coming very soon. Today's webinar is the first in a series. So this is an introduction, and we think we'll follow this up with some more in-depth masterclass sessions over the coming year. We're always looking for really good case studies. So we've got 5 that we'll be showcasing today, and we'll be publishing more on our website. And then it would be great to do some site visits, some more hands-on sessions, and lots more. So if you've got any bright ideas or suggestions for what you might like to see as an activity from our Lime group, please do let us know in the chat. And just an overview of the ways that you can get involved with ASBP. So you can participate in our research. You can join some of the specialist working groups I mentioned. We also have a cross-sector group on reducing plastics in construction. We have over 170 members now, so please do look at joining the ASBP. Membership is growing really well, and it's we had a really good meeting of our latest cohort of 10 or 15 members who joined in the last couple of months. We had a meeting yesterday, brought them all together, and it was just really nice to see the diversity of the members that are joining, but just to find out why they've joined ASBP, what they hope to contribute and gain from our alliance. And then there's lots of really useful guidance and toolkits on our website that you can download. We've got some interesting events coming up. And then our awards is actually closed for entries now, but we're doing something a bit different this year. We're collaborating with the Passive House Trust on something called the Exemplar Sustainable Building Awards. So this is a sort of best of the best of building projects, products, and initiatives. So we've announced the shortlist, and perhaps one of my colleagues can put the link in the chat. But there's an event on the 24th of June where we'll announce the winners. So this is in person and online. So please do join us. Okay, well, enough of me. I will hand over to our group members to introduce themselves. So first up, we have Martin Brown from Best of Lime. Over to you, Martin.
On me. Good morning. Thank you very much. Martin Brown, Best of Lime. We are based in East Anglia, near Cambridge, though we supply nationally. We've spent the last 10 years developing lime plaster systems that are as at home in prestigious palaces and cathedrals, as well as being used in DIY regularly, so easy to use. My presentation today is none of those. I've focused on the potential of traditional lime plaster in new build, in the new build sector. Thank you.
Excellent. Thanks, Martin. Over to you, Adam.
Yeah, good morning, everyone. We're from Cornerstone. We manufacture and supply a range of lime-based materials, plasters, renders, mortars. We have some specialist materials such as grouts and marine-based materials. So hopefully cover all things to do with lime, both for renovation and also new build.
Excellent. Thank you, Adam. Dave.
I think it's Ilias, Richard.
Ilias, Dave.
Oh, it's Dave is gonna. Hello, Dave. He's not there. Okay. Anyway, I'll get this.
I'm here.
Ah, okay.
I don't know what happened there. Yeah, sorry. Yeah, Dave Judd from Ecological Building Systems. Good morning, everybody. Brief history. Our origins go back to 1906. Timber merchants, McCann Burn over in Ireland. 2000, Ecological Building Systems was formed over in Ireland also. Then in the UK, it was a little bit later, 2007 to 08. We're now based up in Cumbria with a growing team. We've got quite a wide range of products. Obviously, the Diason cork and lime thermal plasters, also some lime green products. But also we get involved a lot with air tightness systems. We've got the ProClima range. Do natural fiber insulation, also Butex wood fiber, and recently Indie Nature hemp, which is a very popular product. So our reasons for joining the ASBP Lime Group is just to promote the use of lime in sustainable construction. It basically aligns with our other commitments to encouraging and developing sustainable construction in the industry. and we get a lot of involvement in sort of traditional and heritage buildings. So we like products that are breathable and work with those sort of traditional vernacular structures. So that's us. Thank you.
Excellent. Thanks, Dave. Dominic.
Hello, good morning to all of you. Very good to see so many new faces. My name is Dominic Putnam. I look after marketing and business development of Lime Green product. Lime Green, excuse me, was founded as a current business back in 2002, and business was developed really off the back of innovation and research, and so we are now essentially the UK's leading manufacturer of lime-based building materials. So as you'll see from the slide, we supply and manufacture and supply a very wide range of lime-based materials, and we developed ready to use, easy to use plasters, renders, weather resistant renders, different specifications of mortars for older buildings. We have a range of primers and adhesives that are compatible and complement the plaster product range, and our very specialist plaster areas such as Roman stucco, which is probably better known historically as a product like Portland cement. So off the back of our involvement with lime-based materials, in particular the external renders and internal plasters, about 15 years ago we developed the warm shell insulation wood fibre based systems, and today we're able to offer the market internal solution for this, an external system and a room in roof solution. So all of these things play together, and we collaborate, as mentioned by a couple of previous speakers. We work closely with a number of the other lime specialists in the market, and look forward to picking up with all of you after today. Thank you.
Thanks, Dominic. Oh, sorry, chaps. This is a alternative slide. Let me just find your slide 1 second. I don't know if you have it to hand, chaps. I seem to have mislaid it.
We can just do it verbally. I think I might have it.
Sorry, folks. I had so many slides. I was bound to lose one.
Okay. I can bring it up on this end if you want, Richard.
Yeah, that's okay. Thank you, Tom.
Yeah. It's going to be full of. Let's just do that.
Apologies.
Okay. Oh, yeah. That one. That one. So I've loaded up this one. We don't normally use PowerPoint. That's why there's a million banners at the top.
Thank you.
But we're Mike Y. We supply a wide range of sustainable building and decorating materials, including wood fibre, foam glass, sheets wool cork. But our roots are in lime. We started with Mike Y himself making lime mortars here in a shed on the Buckmanville sawmills, and we've grown a little bit since then. We've now got about 6 warehouses of all these products and quite a large technical team here as well. So we kind of focus on technical support, so it's design advice, installation advice, U-value counts, condensation risk analysis, that kind of thing. And that's been going on for about the last 30 years, hasn't it?
Yes, yeah, no, as Tom said, it's a mixture of manufacturing and supply of various lime-based materials and other connected systems and products as well. And I think we were quite keen to be part of the Lime Group and more broadly the work that we've been happy to collaborate with ASBP when we're often faced with similar conversations when we're dealing with architects or other professionals in the industry. And what becomes very clear through that, as that goes on and on and on as the years go by, is that there's still a great thirst for understanding and still quite a bit of misunderstanding, and also gaps in knowledge and awareness. And that's why I think we feel that being part of the Lime Group is a useful way that we can all make the best presentation of the materials that we're all dealing with to the industry at large, because it is this, we're constantly reminded that you know, you speak to someone and you may assume that they'll already understand or know about the material and the materials we deal with, and it's often apparent that they don't necessarily know as much as you'd imagine. So it's a constant effort to raise awareness, partly for the benefit of us folks in the industry, but also more broadly to do with the benefit that lies in the preservation of historic fabric, and also the benefits we can see with newer construction as well, where other versions of lime and associated materials can really make a difference. So it's all part of the ongoing project that we're all in, I think, aren't we?
Yeah.
Excellent. Thank you, chaps. And yeah, sorry about the technical hiccup then. Right, I'll take over the slide sharing again, if that's okay.
Yeah.
Right, over to Inigo.
Hi, good morning, everybody. I'm Inigo from Astier Limes. I'm the technical manager for international markets. Astier was created in 1912. It's an independent, family-owned company. We are based in France, in Dordogne, and we produce naturally eroded lime and other lime-based products based on our natural hydraulic lime as renders, mortars, or finishing products. Astier lime is the main use in conservation and heritage fields, but right now we are using it more and more in new build. And Astier works in all Europe and internationally, and due to the limestone deposit we have in Astier, we have a very exceptional low environmental impact when we produce our NHL, and that's a unique characteristic of our limes. Okay, and yeah, we are happy and we are new in this group, and we help also on specifications, or we try to help in projects if you have any type of project that you can use or you would like to use lime.
Excellent, thank you, Inigo. Okay, over to Bruno.
Hi, good morning, everybody. So my name is Bruno de Souza. I am the sales manager for SECILTEK, and SECILTEK's man on the ground in the UK. So I oversee operations in the UK and Ireland. So SECILTEK are a Portuguese company. We're a natural hydraulic lime producer, and we were originally founded in 1891. We are the only lime producer in Portugal and the only one in the Iberian Peninsula. Our products have been sold globally, obviously, for many years now, and we've got a global presence in over 40 countries. We offer various products. So we've obviously got the natural hydraulic lime, but then also pre-mixed lime-based mortars. And we also do natural insulation systems. We have one, our main one is one that incorporates cork boards. Obviously cork, there's quite a lot of it in Portugal, Portugal being the biggest producer of cork. So we have a system that incorporates cork insulation boards and then the accompanying mortars to finish off that system. So we have many products, loads of lime-based solutions really for restoration to new construction. And the products that we have are lime-based mortars. Really, we've got renders for base coats, leveling, finishing. We've got bonding mortars as well. for natural insulation systems such as wood fibre, wood wall boards, and obviously the cork boards as well. Our products obviously distributed throughout the UK and can be found in some quite well known distributors who join us here today on the webinar, such as Mike White and Ty-Mawr. And then I suppose our main motivation for joining the ASBP, really, like everyone else, is to help promote the benefits of lime, not only for conservation restoration work, but also in new construction.
Thank you, Bruno. Over to you, Graham.
Good morning, everybody. My name's Graham Griffiths. I don't think I look it, but I have spent the last 10 years in lime and building materials in and around East Anglia. Born really out of a love of old buildings and a degree in building surveying, and then a further course after that in architectural design. In my own spare time, I've restored a cottage and also currently an ongoing project converting a barn. But work-wise, lots of work with architects, lots of work with contractors, homeowners, lots of hand-holding and looking at each property and each project individually. For me, one of the most exciting aspects of lime and historic building materials is the wide range of products and materials. I'm a firm believer that no one material fits all. We get involved with anything from quick lime to ready-mix products. So lots of the St Astier products that we've heard about already from Inigo. And I believe that there's an advantage and a place for all of them. An advantage to talk about products and selling products. I'm keen to share my enthusiasm and knowledge, hence lots of talking to people, whether that be a site visit, whether that be photographs of their project, whether that will be discussing their materials with them. Already this year, we've spent some time doing some training, some product demonstrations with contractors and some homeowners too. We've been involved with some retrofit exhibitions, so run by local councils, local initiatives, retrofitting historic buildings, and a couple of local shows and a London show as well. And that really, I suppose, is what I'm most excited about supporting the ASBP in, is the sharing of the knowledge and the research into materials.
Excellent. Thank you, Graham. Over to John.
Nigel's going to speak.
And Nigel. Thanks.
Hey everybody, thank you very much. So Ty-Mawr was established in '95, based in Wales and covering the whole of the UK, supplying. We're about 20 strong in manufacture and support. We are primarily a manufacturing company. We like producing materials for a wide range of products, including hemp plasters, aggregate plasters, bespoke standard mortars, all of which are hot mixed. And we work with a number of companies supplying, and St Astier and Cecil as well, who supply NHLs and pre-mixed mortars. We design and supply limecrete flooring and manufacture hemp and miscanthus insulation blocks. Provide training on how buildings work and practical application of mortars and plasters, installing limecrete floors and retrofit solutions. We also work with a number of companies associated in the industry, deliver CPDs, run bespoke courses to businesses and organisations. We host the SPAB Fellows and Scholars each year. There's a little picture there of a bit of artistry that one of them produced on a visit a few years ago. We're heavily involved in retrofit, as a lot of other of the presentations have been discussing. We purchased an 1842 former jail a few years ago. We're installing monitors to gather actual data, pre and post date installing of insulation. The product's called Middle Ground because generally you find there isn't one solution to these things. You have to negotiate through the maze of compromise. And those being architecture, listed building consent, repair methods and materials, moisture management, ecology, archaeology, insulation options, heating options, use of PV and other. So it's a sort of thing that all of the other presenters would be familiar with, and how you can advise with people to give them the right direction But I think there's a lack of real data coming back. So I think this is a useful project. So we're working with Welsh School of Architecture, who are recording and analysing the information we're getting from Middle Ground project, and collaborating with various other universities on other projects, Bath and Exeter being a couple.
Thank you, Nigel. Thank you, John. And over to you, Andrew.
Good morning, everyone. Unity Lime, our background is in production of hot lime mortars, hot lime renders and plasters. More recently though, we've sort of more developed into natural fibre insulations. My background is a chartered architectural technologist. I was probably one of the early adopters of breathable materials and products in my own projects, and I sort of joined Unity Lime to sort of help promote breathable products, breathable materials, and I spend a lot of my time sort of training other architects, architectural technologists and specifiers and specifications and how to use everything together. And that's essentially us.
So thank you, Andrew. And yes, Ian from Womersleys sends his apologies. He's unfortunately unable to join us today, but yeah, another member of our group. So thank you to Ian for supporting us. And that's it. So I'll stop sharing now, but just to say a big thank you to all the group members for supporting the group. You know, it's really pleasing. Everybody's, you know, really positive and supportive and sort of gets what we're trying to do with the group, and sort of mirror the successes we've had with our other groups on natural fibre insulation. So yeah, a really strong start, and look forward to working with you all. So right, I will hand over to Peter from Mike Wise. So thank you, Peter, for doing our introduction to Lime products presentation. Over to you.
Thank you, Richard, and yeah, very nice to see all of our colleagues from various different firms. A number of you who I've met over the years, and good to see that we're all joining in with this. I kind of apologise slightly in advance to my colleagues in the industry for whom the presentation just about to follow it's unlikely to contain anything new, vibrant or shocking. It's going to be rather familiar territory, but it is a topic that we regularly work with in our CPD presentations here as a fairly basic, broad-based introduction to what lime actually is, what it does, how it's produced, how we use it, and so on. So apologies, as I say, in advance to those of you well versed in the arts of lime, because I doubt I'm going to teach you anything, and you could probably all teach me a thing or two as well. So there we are. Hopefully, if we got are we up on the screen now? Yeah, lovely. So yeah, building with lime. As we've mentioned briefly, I work at Mike Y. I'm primarily working with insulation these days, but all of us in the company start off with lime, and when we've appropriately carbonated, we then move on to other specialities in the company as well, wood fibre insulation, for example. But it tends to come full circle, and lime will keep reappearing in all of this because it's a very versatile binder in mortars and plasters, and therefore has a range of benefits, which we'll have a look at in a moment. So we'll have a quick look at the long history of lime, but very, very briefly. The lime cycle, which I find particularly fascinating. If you're someone who's interested in materials and processes and chemistry, then you will also, I'm sure, find it equally fascinating. We'll have a brief look at forms of lime, benefits of lime, and a very, very quick look at a couple of examples, specifications, or types of use, and how we would recommend the material is used. I will also have to add at this stage that, as has been pointed out already, there isn't one solution that fits all, and you will also see a really quite a large potential range of advice out there. And the world of lime is full of entertainment and dispute and discussion, and the occasional disagreement as well. And we're always very keen to point out that we base our advice on the materials we've made and the work we've done over a number of decades. But we're also very, very keen to encourage that contractors, professionals, property owners, and so on, homeowners, take the time to look at a range of advice and to consider nuances and differences in all of this, because there are some. In terms of history, lime is quite an ancient material, and I do point out that it is the mineral binder used in a range of materials for building purposes. And the mineral binder is, as you can appreciate, used with other forms of aggregate and other ingredients in order to achieve the objectives of a particular project. As far as we are aware, the earliest recorded evidence of lime burning was from Mesopotamia over 2000 years BC. And the actual use of lime predates that as well. It's likely that it was thousands of years prior to that. Quite how lime in the form we used, in a reactive form for building materials, was originally discovered is open to conjecture. There are theories that it may have been a very vigorous fire with early humans surrounding it, and very, very great, a huge amount of heat to which the stones around the fire or under the fire were exposed. They underwent a change, and then I'm sure if it poured with rain on those stones and the fizzing and the reactions took place, even people of that era would have been quite curious to understand what was going on. But who knows? No one really does. So there's evidence of lime having been used in the construction of the pyramids, also Great Wall of China, and probably from our point of view in the UK, most significantly the Romans, who began to develop a true understanding of what lime could do and how lime could be used. And they, of course, arrived in this country, was it 43 AD or so, and we're here for a good few hundred years or so. And in that period of time, the use of lime was introduced to building in Britain at a very early stage, and some of those structures still remain now. Rather wonderfully, nice illustration there of the baths in Bath. The use of lime in this country somewhat dwindled with the departure of the Romans, or at least with the establishment of Britannia and the exit, as it were, of the empire as such. And in the UK, a lot of building in early pre-medieval era was primarily earth and stone and timber. Wattle and daub, for example, was quite commonplace, which is just a lattice work, usually of hazel interwoven, and then effectively smeared with clays and earth and other materials that came to hand. And further down the line, the appearance of lime as a binder went more hand in hand with the development of building materials, for example, bricks and so on. We do like to talk briefly about Mr. John Smeaton, who was he was a surveyor. He had various hats that he wore, and wigs as well, by the looks of it. One structure for which he is very well known is was known as the Eddystone Lighthouse in its early form. That was then reconstructed partially on Plymouth Hoe, where it stands to this day, known as Smeaton's Tower. That was a fascinating structure made from granite blocks, all of which were cut to individual, unique, specific shapes and tessellated and interlocked in a fascinating way to produce a structure of immense strength. He was the gentleman credited really with the understanding of the hydraulic behavior of lime and the development of natural hydraulic lime, NHL, which we'll get to in a minute or two. I mentioned briefly the lime cycle, and I do apologise, I will have to slightly rattle along through this because I can go on and on and on. The lime cycle, an incredibly satisfactory circular motion, as it were, of material. We're starting out with the actual raw material itself, limestone or chalk. And nice illustration here of very prominent, well-known features southeast of this country, down towards Dover and that part of the world. And we're starting off with calcium carbonate, the limestone itself. The calcium carbonate limestone is put into a kiln and fired with combustible materials, usually at about 700-800 degrees Celsius or thereabouts. The illustration here, I believe, is actually of a lime kiln, not in this country. I think it's North African. Somewhat fascinatingly, you quite often find lime kilns in coastal marine locations. I know along the coast where we are, which we're very lucky, it's absolutely glorious. There's quite a lot of lime kilns on the coast there because limestone is not commonly found in this part of the far southwest of England, but it is of course available from Wales, and in many cases Welsh limestone would be brought across the Bristol Channel. They would sail the boats as close to shore as they could at high tide, dump the contents of the vessel over the side into the water, sail away before the tide went out, and when the tide had gone out, the local people involved in the manufacture of lime would gather the limestone, bring it up the beach, and from there it would be fired in kilns to create quicklime, calcium oxide. So in the process, we've got carbon dioxide, which is being is released during the burning, and we end up with quicklime. Quicklime is effectively the substance from which building limes are then created, and there are a few different forms of lime and forms of material that result from this. And those forms of material are often derived from the natural properties of the raw material of the limestone itself, the purity of the limestone, and somewhat cruelly, the impurity that might be found in it with other compounds, which could lead to different behaviors in the lime itself. So we have quicklime. Our processes here at Mike Y, as I'm sure many of you else in the industry would also be familiar, we're taking quicklime and in our operations here, we're slaking it, which means putting it with an excess amount of water. You get a very, very vigorous exothermic reaction, lots of gas, it boils in its own reaction effectively, lots of heat, and this results in a milky, creamy fluid, which is then left to settle in tanks for a number of months. The quicklime itself, it's highly alkaline, it's quite caustic, so it is material which needs to be treated with great caution. On the manufacturing side, we're doing this under controlled conditions, as you can appreciate, with safety gear. However, of course, we'll touch briefly on hot lime in a minute or two. It is a process that is still carried out on some sites to this very day, and we'll have a quick look at that in a minute. So we've got effectively a milky substance which over a period of time matures, the water is driven out, and we're left with lime putty, which is a bit like cream cheese in appearance. And that is then mixed with sands, aggregates, or if we're making lime wash, with water, and that will create mortars and plasters, which are then used either for construction or surface coatings on buildings for repointing and so on. And what we then find happens further down the line, of course, is where we're looking at lime putty mortars, they're not, in this case, hydraulic materials. So we're looking for the curing or the setting process to happen quite gradually by a process of carbonation. It's reacting to and reabsorbing carbon dioxide from the atmosphere over a reasonably long period of time. And in the end, we find a material or an end result which is somewhat similar to where we started out. And this is what I find particularly fascinating, is that we're taking a raw mineral and processing it, we're modifying it, adding materials to it, forming and shaping the structures that we wish to, and then in the end, it provides us the benefit of returning almost to the substance from whence it came. Natural hydraulic lime, and this is a subject of often of some confusion between various forms of lime and how and why we would use them. We have natural hydraulic lime, and on site for use in projects, for example, this is going to be a substance which is supplied in dry powdered form. It is then mixed with appropriate sands at a ratio which has been decided in that particular case is appropriate for the job, and then water is added, and that creates our end result, our mortar. Natural hydraulic lime is produced from raw materials which contain natural compounds which produce the hydraulicity in this material. Lime putty, which I've mentioned briefly, also known as air lime, and a whole range of different frames and terms of reference, many of which are perhaps regional, and thus we can end up in a somewhat confused situation, especially for the uninitiated or people new to the topic. Quicklime, as I mentioned, that's the reactive fired limestone product that we're starting with. We have lime putty, we have hot lime. Hot lime is an excellent and very interesting subject, and also the one of some debate in the industry itself. A hot lime mix, I mean, as I mentioned, we're making lime putty, then mixing it with sand as our primary haired and unhaired mortar products. Hot lime is a different is a different route to a similar end, not the same, I must point out. A hot lime mix, you could argue in many cases, is perhaps a very historically correct or appropriate way of mixing a lime mortar. As you can appreciate, in times gone by, if you were building your structure, you may have access to limestone, which you would fire yourself. You may have access to quicklime. You would have access to sands, aggregates, and other materials. And on site, the prospect would be to create an area, dig a pit, whatever it may be, add the quicklime and the sands and aggregates together, put the water in, and the mortar is formed within the heat of that exothermic reaction. It's a hot lime mix, and we do get asked about this at Mike Y. We're somewhat hesitant to advise in detail. The way we tend to look at it really is if it's in the hands of a skilled practitioner who understands the material, how to handle it, how to produce consistent, regular, successful results, it's a great way to work. If we are talking to someone who evidently doesn't necessarily have that sort of background or knowledge or skill and may not have it available on site, we would tend to slightly step back and suggest that they may wish to seek the advice of a more specific expert in the topic. It does produce a very lovely workable mortar with very good adhesive properties, and for some projects, especially if it's sort of by the decision of a conservation officer, for example, it may be considered partly because of its properties, but also because of the historical alignment with the original structure itself. Natural hydraulic lime, which I mentioned already, is produced from limestone, but with different compounds and contents within it. Hydraulic lime, natural hydraulic lime, one of the key points is that it has a chemical initial set. It has a hydraulic set. It means that the material you're using will gain compressive strength much more rapidly. And for many purposes, for example, actual construction, if you're laying brick or laying stone in a wall, as you can imagine, there is an advantage in using a material which gains compressive strength at a slightly earlier stage, thus allowing more progress to be made. Natural hydraulic limes, NHLs, do by nature produce a slightly harder result than you get with putty or with hot lime. This is also another area of some debate in the industry. We're keen to point out that this is still a very long distance away from Portland cement, which is clearly very well known in terms of its properties as a material. But natural hydraulic lime has many advantages in certain applications, and we have for a long time been very pleased to supply NHLs. We've been, as Bruno mentioned there, with the Portuguese NHLs, which we've been very happy to deal with for quite a long time now. And for the right work, it's an excellent way to proceed. NHLs, natural hydraulic lime, very briefly, comes in 3 strength designations: NHL2, NHL 3.5, and NHL 5. With the increase in the designation comes an increase in mortar strength and hardness, and also in the speed of the setting process as well. We would tend to use NHL2 for perhaps more sheltered works, slightly softer building fabric and substrates, for internal work perhaps as well. NHL 3.5 we find very useful in general terms as a bit of an all-rounder. And NHL 5 we would tend to reserve more for use in highly exposed positions, chimney flaunchings and so on, or for buildings with extremely hard brick or stone, for work that might be at or below ground level, and also for floor slabs, which I'll mention briefly in a few minutes' time. And formulated limes, this is an area that possibly holds increasing interest when we work with insulation materials in particular. Formulated limes are generally a product which is supplied usually as a dry premix. So it contains generally NHL, natural hydraulic lime, as the binder, with selected grades of sand and aggregates. There are various products available for specific purposes, formulated to do that job in the best possible way. These are materials which are delivered to site, and then usually it is simply an addition of water, correct volume of water and appropriate mixing, and then the product is ready to go. And we can sometimes look at formulated limes with older buildings from time to time, but the focus really with formulated limes, at least in the work we do, tends to be more to do with insulation materials, although there are some excellent products which can still be used for renovation purposes, subject to approval by those concerned. Lime has a number of benefits, and we're quite often looking at this in context of comparison with cement. Cement, OPC, Portland cement, has been broadly used in the UK for a number of years, and understandably so, although in many cases it has proved to be detrimental to the structures involved and has produced various problems. Cement has some similarities to hydraulic lime in essence in terms of the origins of the raw materials, but there are differences in production. Cement is produced at much higher firing temperatures, for example, and the end result with cement is it's a hydraulic binder used to make mortars and other materials, concrete for example, which by nature produces a very, very hard and robust end result, but at the same time it also is less breathable, it's less vapor permeable. There are some jobs cement does so well that it's hard to find an alternative. If you need to create a concrete structure, using cementitious binders is going to be the way you will proceed, because that form of work and those forms of structure require that kind of strength. However, there is a downside to this, as we will see, if we're looking at older buildings or some forms of new build as well. So we're talking in terms of comparison with cement quite a lot of the time with lime. The lime materials have a greater level of breathability in terms of allowing moisture vapor to pass through the material, and they're hygroscopic. They're able to bond with and hold on to humidity and moisture and then release it again without the material itself suffering or decaying in the process. Lime is also regarded as a flexible building material, and that is in relative terms. If you have a patch of lime render and you bang your head on it, it does still really, really hurt. It is properly hard stuff, but compared with cement, there is relatively quite a big difference. And that flexibility can have huge advantages, as we will see. It's sympathetic to the fabric of a building. And the breathability and the relative flexibility are key tenets of this sympathy. In essence, we want the fabric of the building, the stone or the brick, to be the harder component, and the mortar that's used to point or to bed these materials is going to be relatively softer and needs to possess a good degree of breathability. And in a sense as well, with lime pointing, it's a sacrificial chunk of material. If you have a brick or a stone wall that requires some repointing work after a period of hopefully many decades, better to repair the pointing than to have serious issues with the brick or the stone that requires rebuilding or replacement of the material. If we're looking at a brick or a stone wall, for example, and the comparison between cement mortar and lime mortar, which is very often a comparison we find ourselves making, we're looking at the mortar joints and the pointing effectively to be conduits through which we can encourage the passage of moisture. Solid masonry structures, by their very nature, will always have a certain moisture content. This will come either from condensation within the wall, or it can come from condensation on inner surfaces, and it can also obviously come from the arrival of weather on the surface and the invasion of moisture. No matter how well maintained a brick or stone wall is, especially without a render coat on there, no matter how well the wall has been done, there will inevitably be moisture finding its way into that wall. What we want to achieve is a state of equilibrium so that moisture which arrives can then vacate again. The wall will be in a state of balance. We won't see an undue accumulation of moisture, which can have major issues with the fabric of the building and the performance of the wall thermally as much as anything else. The mortar joints, therefore, in a more permeable lime mortar will allow further vacation of this moisture content. If we have cement in that position instead, it can cause the moisture to become trapped in the wall. If we've got cement pointing, for example, on an older wall, brick or stone, the hardness and the relative brittleness of that cement, as well as its impervious nature, tends to mean that we may have cracking appearing due to minor movements in the structure, and those movements are much better accommodated by a slightly more elastic mortar, for example, made with lime. Therefore, we can have an increasing mechanism and cycle of water ingress into the wall, which can then only pass through the brick or the stone because the mortar itself is largely impervious. This can have serious issues to do with freeze-thaw damage and spalling of brick or stone during the winter time, when we have saturation at the surface and ice crystals forming and causing the material to become weaker and weaker. And also, if we have a lot of moisture moving through the brick or stone, it can bring with it salts, which will then evaporate, or the moisture content evaporates near the surface. The salts will then crystallize, and similar to the formation of ice crystals, it can be quite damaging to the fabric of the building. This
sorry to just to give you a 2-minute warning. I'm sorry to
oh no, Richard, right, I'll put my skates on. This is an old diagram which I must say I inherited from someone here at Mike White quite a long time ago. I'm not too hooked on the figures. It's really just a graphical representation of the relative permeability of lime putty working through the designations of NHL and then cement. And hand in hand with that, we have an illustration of what we might find as typical values after around 12 months have passed for mortar strength or compressive strength with the limes and with cement. As is illustrated there, cement occupies quite an extreme position out on a limb on its own. I mentioned briefly the idea of cement mortars being detrimental to old stone, for example. This is a village in Northumberland. At the top of the picture, you can see historical older lime mortar and the stones which it surrounds still presenting faces relatively close to where they started. This wall's been repaired with cement. As a result, the acceleration of the decay of the stone, this is sandstone, is quite pronounced, and the cement pointing is now standing proud. And this is an extreme example, and in this case, the damage on this wall, you can fit your hand inside some of these features. So an extreme example, but nonetheless a useful one. Very, very quickly, here we have, and if you've got a cob building, don't worry, this is an extreme situation, and I am informed no one was in bed at the time this happened. This is a cob building, an earth structure, cement render on the outside. Moisture has got trapped in the wall. The cob has become weaker and softer. The cement render has delaminated. The cob structure has failed, and lo and behold, there's a situation that could have been very possibly prevented with an appropriate lime render. I won't have time to go through the example specifications in any detail. Get back to us if you'd like to have a look in this in this department a bit more closely with us. We'd be very happy to talk to you about it. But in essence, external render, we're throwing a slurry of lime on the wall first to give it a key. Then we're doing a scratch coat of head mortar about 15 mil thick to give the form to the wall. Then we're returning to do a final float coat with unhead mortar. We're adding a bit of pozzolan, which I didn't have time to talk about. That's just an addition to lime putty to give it a bit of a kick in the backside and speed things up and give it some early strength. It introduces a degree of hydraulic activity into a non-hydraulic mortar effectively. And what we're finding we're working with more and more now, and on the formulated lime side of things, is wood fibre insulation, where typically we're using overall much thinner coats of render and plaster using formulated limes with meshes embedded into those. In both of these cases, we're also going to encourage the use of appropriate breathable paints as well as a final treatment, although there are some coloured products as well. But as I mentioned, formulated lime becoming ever more interesting in the work that we do, although we're always going to have one foot in the past, as it were, with the more traditional lime side of things. And as I mentioned very, very briefly, the use of NHL5 in floor slabs, in this case our Glasscrete system, Limecrete as it's often known, using recycled foam glass aggregate to insulate and provide a capillary break. It's a load-bearing material once it's compacted, over which we have a slab of material made with NHL5 at a fairly sort of beefy, strong mix for durability. This produces a breathable floor system that's very sympathetic with older buildings, although variations on the theme can still be used in more modern structures as well, subject to approval by building control and so on. And as is always the case with all of these topics, if anyone's curious to get back to us for a bit more detail, we'll be very happy to have a chat. So I think, Richard, I might have just about absorbed the final 2 minutes. I'm not sure if I came in on time there, but I will just briefly mention it's a very, very broad topic, so there's not a huge amount we can get through in the time we've got, but hopefully for the uninitiated, that might shine a bit of a light on a few bits and bobs and provide some food for thought at least.
Absolutely, yes. Thank you very much, Peter. As you say, it's a huge topic. So this is the first in a series, shall we say. So more webinars to follow with more time, and we can get into the detail a bit more. So yeah, thank you very much. So if you wouldn't mind stop sharing, that would be marvelous. Okay, right, moving on swiftly, we're on to our case studies now. So I will share screen. Okay, hopefully you can see nice blue slide. So we've got 5 case studies showcasing a range of different applications, and I'll just go straight into it. So I'll hand over to Martin, who has a new build case study. So over to you, Martin.
Thank you, Richard, and well done, Peter, on summing up the entire Lime history in a few minutes. Okay, so our core business, as with pretty much all the guys here, is building conservation, historic buildings, listed buildings, etc. So I thought I'd do something a little different, which is a few projects we're getting involved in more now, which is new build, and specifically trying to get traditional lime plasters used more in developer situations, rather than a lot of us will be involved in sort of specific builds where people want to do environmental low carbon builds. That's kind of the low hanging fruit. What we're really interested in is trying to get more involved in with developers. So this is a little project of 3 houses that we were involved in. I've broken them down into 3 kind of basic areas. The first 2 are those that are most of interest to a developer, and then the last one is kind of where hopefully the future is going. So cost-wise, these are quite nice timber framed, modern timber framed new builds, done obviously to have a traditional look to them. So the original specification, this covers cost, the original specification was for 3-coat sand and cement over EML. The point being that they wanted to have rolled corners and give it a kind of traditional feel. We managed to convince the developer on cost that they were going to pay more for the materials, but effectively with warm coat being lightweight, they could take a coat out, so turn it into a 2-coat system. So the extra spend on materials would hopefully see a third less in labour costs and still get a traditional look. So second of interest to most of the smaller developers, and I think now more of the medium to bigger ones, is trying to make individual looking houses rather than just rows of boxes. So the aesthetic look of the building, most of them want to stand out from the crowd a little bit. So the use of the lime plaster gives a very much more visually soft look. You're able to roll the corners nicer. You've got much more flexibility, so you're much less likely to have any cracking issues on corners, which are often the case with standard cement. Yeah, a softer visual approach than modern silicon renders and obviously standard cement. A little bit of detail. So this particular build, as well as the rolled corners, you've got some rather nice little chamfer stop details at top and bottom underneath the jetties. So that just gives a little bit of, again, a little bit of visual difference that can be achieved much easier and more confidently with a lime plaster than a modern material. So number 3, and possibly not yet at the top of the list with developers, but hopefully we're heading in this direction. Some back of fag packet calculations here. So a 4-bed detached house, 170 square meters of sand cement render. Production emissions of CO2 going to be over a ton. So here we've worked out 1,172 kilos of CO2, 900 of which will certainly not be absorbed, and that's probably being generous. So a 900 kilo CO2 kind of emission cost on that build. The warm coat and lime coat system, obviously much less embodied energy into the manufacture of the product. We think that 347 kilos would not be reabsorbed using that particular process. So that's a 550 kilo saving. Work we're doing at the moment with our lime coat product suggests that you're actually sequestering CO2. So we think at the moment that 170 square meters of render could effectively lock away 2.25 ton of CO2. So that's where we're at the moment.
Excellent. Thank you, Martin. Really interesting project. Looks like a lovely house. Right, over to Dominic from Lime Green.
Hello again, everybody. I would like to just quickly take you through an example of one of many case studies that we've worked on in recent years. It is very product focused, but I think an interesting one to just share details with you on. We were very fortunate. Some of you may recognize this building, those of you who go around London a lot. This is the old Westminster Fire Station in London, Victoria. It was built in 1906. It's a Grade 2 listed Edwardian station, which was actually decommissioned in 2014. Project has 2 parts. So the refurbishment of the existing building to create a restaurant and housing, and a new residential building to the rear of the site, which together define a new garden courtyard. The external volume of the new building is stepped, cut back, and inflected to respond to the densely built-up context. The design integrates pale bricks and iridescent glazed bricks to form a light reflective structure, which refers to the pale Portland stone at the base, glazed bricks on the interior of the fire station, and the history of brick building in Victoria. Horizontal brick courses of iridescent set at floor levels of the adjacent fire station trace the lines of the fire station walkways over the new brickwork, weaving old and new together. The project was completed in March 22. Next slide, please, Richard. So one of the key elements, obviously, as with all projects, particularly where it's involving construction of a new building to be compatible with an existing building, was the selection of the materials. So these words that I'm sharing with you are from a case study that we put together with the architect, Jennifer Benningfield, principal architect of Open Studio Architects. And so many of these words are directly from her. So as you'll see here, it's an impressive structure. And so their overview is that working with Lime Green, they managed to develop a solution that matched the original building's beautiful aesthetic and historic character. They received a lot of praise for the high quality and beautiful new courtyard building. The lime mortar is an integral part of the brickwork and proves that it is appropriate for contemporary as well as historical structures. Finding the right colour mortar to match the pale Danish bricks was key. These bricks were handmade, so we needed a mortar that integrated with the historic Edwardian building to create a seamless whole. The flexibility of the products also helped us to minimise the amount of movement joints, as it accommodated movement in a much more forgiving way than other products, such as modern cement mortars. Next slide. So obviously crucial to the success of this project, which was recognised being shortlisted for a Housing Design Award, was the materials used would be sustainable, natural, and provide a beautiful finish for the building. So people love the building, and neighbours even call it the Golden Citadel. It's widely recognised in the local community for its high quality, beautiful finish. One of the fire station's previous residents, who had moved out during the construction, has moved back after the restoration works and loves the development. So we're enhancing people's experience of new buildings made with sustainable and natural materials that stand the test of time. The Westminster Fire Station development truly looks beautiful, and the quality of the natural and sustainable products used has a huge role to play in that. So another important element is that we were, sorry, did we miss a slide, Richard? Sorry. Beg your pardon, okay, thank you. Obviously, we were also needing to work with the local community, as with any major development in a built-up area. So with its central location, this construction work undoubtedly had an impact on those living and working in the local area, which is why the architect wanted to ensure the community were completely happy with the project. The restoration of the fire station and regeneration was all about creating an experience for those that live there. You'll see from this image that the building on the right-hand side is the original building, which were converted to apartments, and the new construction behind it. So they were using sustainable and natural materials to achieve accommodation in the local construction area. And finally, so this project was in fact shortlisted by REBA for its London Award, which is under consideration at the moment. So I think we can safely classify it as an award-winning project. When the architect was planning the project, they recognised the importance of lime product because of the material's sturdiness and robustness. This means it doesn't wear with structural movements and changes in the seasons. The best part of the project for the designers and architects was that they were able to develop a solution with us at Lime Green that supported the original building's beautiful aesthetic and historic character, with a new building that pays similar attention to detail. If any of you are interested in looking more closely at this case study, please hop on our website or jump on the website of Open Studio Architects. The link is shown there at the bottom. Thank you.
Thank you, Dominic. Another really interesting project. There was a specific question about the project in the Q&A, so I think we might be a bit tight on time. So if you could have a look and type out a response, that would be fantastic. And likewise for the other group members, if there's any questions in the Q&A that you think you can respond to, please do type out an answer. And if we've got time, then we'll do a few quick Q&A. But I will, yes, hand over to our next case study. So over to you, Graham.
Thank you very much. I'll see if I can make up some time. So my case study revolves around conservation and raises 3 points that I think might be quite interesting. The first is material analysis and replicating their findings. The second highlights a couple of points made already by Peter, so choice of materials and type of lime. And then the third one, I have happened to notice no one has mentioned Italian food yet, so I'm going to talk a little bit about lasagna. So this is a project, it's an ongoing project run by the Fenland and Wash Regional SPAB Group, so the Society for Protection of Ancient Buildings. It's a property called Wangford Hall near Lakenheath. It's right on the edge of the runway at Lakenheath. It's been derelict for several years, and I think unless you're a real fan of aeroplanes, you'll understand why. So it's a building that wasn't what we were there to look at, but it's a fascinating building. In any case, it's a 16th century hall house with later 18th and 19th century additions. But we were there to look at the walled garden. So surrounding the property, there's the remains, I suppose, of a walled garden. Originally designed by Gertrude Jekyll, so a prolific garden designer. She designed this garden in 1928. It costed 12 guineas. It was one of her 350 gardens that she designed in her career, half of which she never saw. The garden wall that surrounds it is constructed in flint, chalk, block, and brick. Parts of it have collapsed. Parts of it were in poor repair. And I suspect some of it is probably now underneath the runway as well. Can we have the next slide, please? Thank you. So mortar analysis formed part of our materials analysis. So the samples of the mortar were sent off to Hassan Sheridan, who analysed them. He revealed that the mix was a very lime-rich, so I suspect a hot mix originally, mortar, comprising of a non-hydraulic chalk and a soft sand. So the intention, which is in line with the SPAB ethos, was to source local materials. And this formed part of a working party. There's been 3, I think, working parties there so far. So it's volunteers with an interest that are helping to repair the wall. So we wound it back as far as we could go. So we began sourcing local materials, which is where my lasagna analogy comes in. So what we were really doing was sourcing and creating all the materials right from scratch, in the same way as we might if we were making a lasagna. We might feed a hen to lay an egg. We might grow a tomato plant to provide the tomatoes and grow the wheat to create the flour. So this is a bad thing. What it does do is takes an awful lot of time, an awful lot of knowledge. There is a cost implication. There is a waste implication as well. We need to think about what we're going to do with that hen once it's laid the egg, and convenience implications as well. Next slide, please. I think for me, one of the most interesting things about lime is the difference of opinions. You can see these on forums and Facebook pages all the time, but also the difference in materials. My pallet racking here, I'm sure lots of other people exactly the same, contains stocks of quicklime and putty and NHL binders, but also products designed for very, very specific performance and applications. So products that are bagged, generally dry mix products that are bagged, but have been rigorously tested, designed in laboratories, produced in factories. So they are consistent materials with data sheets that's available. So we know with some of these more modern products what we're going to end up with. The whole interesting thing about lime is its versatility. So we know with a lime building, we can do anything from the floor right up to the chimney pot. So we've heard already about floor screeds. Plinth repointing is possible with lime. Dealing with problem salts is possible with lime. Grouts for voids, plaster interiors, rendering exteriors, stone repair mortars, preparation plasters, so things like the Eco Mortar R series, right up to above the roof lime mortars designed for that quicker set, so we can set our chimney pot on the top. But the point I'm making is we wouldn't use the same materials in all of those situations, but we can certainly use a lime in all of those situations. When it came to sourcing a sand, we conducted a desk survey, so we looked at local quarries. Sadly, several of them closed now, but we tried to source a sand that was probably as close as we can, probably used when the wall was originally constructed. So we obtained samples from the quarries. We made biscuit-sized mortar samples. We looked at the colour and the texture. That's important. But it's also very important to look at the performance of the material that we need. So rather than just blindly using, like was analysed, the soft sand, reusing the soft sand, what we actually did was from the same quarry sourced a coarser sand. So not quite as historically accurate perhaps as that initial sample demonstrated, but in our opinion, and it was a reasoned discussion, in our opinion, a better product to be using, bearing in mind what we know about the lime now and the products that we had at hand. Thank you. When it came to binder sourcing, again, this is winding the clock right back as far as we possibly could. It was our intention to go to a quarry and take chalk and then turn that into a binder suitable to be used with a mortar. So we were told to go on a dry day. We didn't. We went on a very wet day. We climbed up a mountain of chalk and we sourced some chalk, 75 to 100 mil pieces of chalk. We sourced 5 kilos originally. That was taken away and burnt in a kiln just to make sure that it would burn and it was a product that was suitable. When it was decided that it was, then we collected a further 300 kilos of the same sized chalk from the same place, which was then taken away and burnt rather, at the SPAB kiln in Kent, their old house project. And once it had been burnt, we I wasn't involved, they sprinkled it with water. So what they created was a dry hydrate, so effectively a bagged lime that was returned to Wangford. So what we had created then was our lasagna right from scratch. We've replicated a non-hydraulic mortar, very, very similar to the original sample, using the most local materials that we possibly could. Thank you. That's it, lovely, thank you. The binder sourcing, though, we did move away from that. So although we'd created what we thought was a very good match for the existing mortar, although we had changed the sand, you remember, to a better sand in our opinion, but there was a realisation that in certain points of the wall's construction, that binder, that mortar that we created wasn't going to be the best one. So there were parts of the wall where the wall had collapsed, where we needed to create a buttress. And in those situations, we needed something that had a greater compressive strength and a greater speed of set so that we could continue with the work. So in those situations, we chose an NHL. So the analogy here is along the lines of using a prepared sauce and a prepared pasta sheet. So we're using a product that is convenient, has been tested. We know what the outcome is going to be because we've seen it before. We could have, and some of the purists might say that we could have used a pozzolan. We could have done, but it would have just been another batch of sourcing another material, testing it, checking the ratio, doing samples. So what we used there was a material that we had that was the right one to be used in our opinion. So finally, to conclude, the conclusions: importance of analysis. It is important to do the analysis. We respected the the materials that were rare originally, but when we were looking at them, we made a reasoned decision not to replicate blindly what they had used previously. And it highlights quite well, I think, that there is a mortar for all purposes. We need to consider the properties and the requirements. One lime doesn't fit all. We couldn't have used our mortar that we created from the chalk in those foundations as successfully as we used an NHL. And the design that's best for you, based on convenience, based on cost, based on the skill set of the people that are using the materials, like has been mentioned before, and their knowledge of materials, ratios, usages, and wastage. Thank you very much.
Thank you, Graham. Another really interesting project. So thank you very much. And thank you for our speakers for typing away their responses to the Q&A. If you could just keep doing that. I don't think we'll have time to do any verbal Q&A this time, I'm afraid. But okay, on to our second to last case study. Over to, is this Ilias or Dave?
Yeah, that's me. Thank you.
Thank you. Ilias, if you wouldn't mind rattling through, I know you've got quite a few slides, if that's okay, just so we
I can.
Thank you.
Do you want me to share my screen then? Yeah.
No, I'll share your screen, but if you could go through with efficiency, if that's okay.
Okay, yeah, I will. Yeah, no problem. Okay. So yeah, this is a Victorian Mews house in London, very charming and, you know, with character. But this was really cold, drafty, and expensive to heat, and the owners wanted to improve the comfort and reduce energy bills. So for that reason, they decided to follow a deep retrofit strategy, focusing on insulation, airtightness, and a low carbon heating, like a heat pump, and at the same time preserving the character of the building. So the design was by Pruitt Beazley Architects, very experienced heritage architects in London, and it was including like a breathable lime cork insulating plaster for insulation and moisture management, evacuated glazing sash windows, and a highly efficient heat pump. Next, please. Can you also play the video, Richard, please?
Yeah.
Yeah, thank you. Okay, so in order to insulate the solid brick walls, first they strip back to the original masonry, and then they sprayed diathonite in 2 layers to around 25 millimeters each, so 50 millimeters overall, and then finished off with a smoother Argatherm smooth lime plaster. So diathonite is a lime and cork based insulating plaster with also lightweight volcanic ash materials and diatomaceous earth. And it's very vapor open, hygroscopic, and very absorptive, very capillary active. So it has the capacity to wick the moisture off the wall and move it through, avoiding any trapped moisture behind. Next, please. So they achieved a U value of around 0.54. Can you click, please? There is a chart there. Yeah, okay, so you see this chart. So this was about 4 times improvement in comparison to the initial U value, which gives comfort and at the same time regulates moisture without harming the building. Next, please. That's also, and the next one, please. So there is a graph here from our goofy calculation that shows that the average relative humidity in the diathonite layer is around 77–78%. Which is much lower than the 95%, which is a benchmark that the risk starts occurring. So very safe construction. And yeah, this was kind of a modest U value, to be honest, especially in comparison to new build standards, but a safe improvement in this case. So the walls are now much warmer and the comfort has been improved significantly. And at the same time, the character of the building have been retained. So this lime-based insulating plaster is kind of an ideal solution for these types of constructions, unlike rigid plasticky foam insulation and or vapor barriers, which can trap moisture behind. So yeah, after 19 months of monitoring, which slide is that now? I need the table now. So the previous one, please.
I'm sorry, Ilias, my computer is having some overheating issues. Can you hear me?
All right, okay.
I don't know if you're able to share.
Okay, yeah, I'll go through. Yeah, yeah. Okay, so the previous table shows like all the results after 19 months of monitoring. So there is a significant improvement in air tightness. So from 10 air changes per hour, it went down to 1.2 air changes per hour. The energy use intensity dropped from around 300 down to 50 or 51 kilowatt hours per square meter, which is within the LETI target range. The space heating demands reduced from 240 down to 40, which is much better than even the criteria for constrained properties, which is 60. And the gas boiler, the switch from the gas boiler to air source heat pump, which was like much more efficient. So the efficiency went from 90% to 360%. So that's significant. So all this, the combination led to a major reduction of operational cost, carbon emissions from 65 down to, I think it was 12. So yeah, 4 or 5 times better. So we can see in this case, there was a highly efficient construction or retrofit from the energy, but also from the carbon point of view. And yeah, so I'm lost now. I have no slides.
I'm so sorry, Ilias. I wonder if my colleague Larry could stop my screen sharing. I'm sorry, my computer's exploded under all the fantastic presentations. It's just completely frozen.
You're not screen sharing at the moment.
I'm not screen sharing. Okay, right, Larry. I don't know.
I'm sharing my screen now.
Okay, fantastic. Sorry, I cannot see anything. I do apologize.
No worries. Look, okay, that was a table. Was almost correct, the numbers I mentioned there. Anyway, yeah. Also, this graph here shows the before energy performance, and the mid column shows how significant the improvement was with the fabric improvement, only 80%, and the right hand one shows the overall performance, including the heat pump. So you can see that this combination works very well. And look, that was it. Just to recap a couple of words here. So this approach shows that traditional heritage buildings can be saved literally in the UK, like deeply retrofitted in a very safe and sustainable way. Using these types of materials, though, natural materials, hygroscopic, capillary active, like lime-based materials, to manage the moisture safely. This combination, of fabric first approach added with a low carbon heating works very, very well. The obsession with very low U values, should be a little bit more modest here. Always we need to have a balance, but however, achieving very, very good results. And the design ambition can, doesn't have to compete with carbon, emissions. It can always go like hand in hand, and get like amazing results that are sustainable as well.
Thank you, Ilias. And sorry,
I'm really stressed, but yeah, hopefully.
Major technical difficulties then. Adam, I don't know, are you able to share your own screen in your slides?
Yeah.
Thank you so much. My laptop was about to take off into space then. It was...
Can you all see that?
It's just loading up. Yes, perfect. Thank you.
Okay, so this is a relatively large-scale renovation along some sort of custom works. The building in question is called Qasar Al Hassan. It's based in Abu Dhabi. It was the first permanent stone structure within the city. So it really encapsulates the development of Abu Dhabi and UAE as a sort of wider nation. Originally constructed in 1760s, it basically served as a fort or a watchtower to guard over a freshwater well that was in place. Then as sort of time moves on, in the late 1790s, additional towers are added, and eventually created a fortress that was used to oversee shipping and trade routes. It also served as a defensive structure, and it actually served as the government and military headquarters, as well as the ruling sheikh's permanent residence. The name translates to Palace Fort. Now, unfortunately, as we've already seen, the sort of damages that can be caused with renovations and sort of cement-based materials, over time there have been a lot of cement mortars that have been introduced, modern paints, This building itself has quite a unique structure. It's a vented wall, which is known as a bargeal, which essentially is a form of natural ventilation. So it relies on a recessed arches that go along the walls. That basically brings in the prevailing sea breeze, and then that's filtered through a network of airways. Due to more modern interventions and additions, they started to find severe structural issues within the walls of the fort, and they were quite worried about collapse. Now, as part of our remit, we were contacted by both engineers and specifiers involved in the project, and in partnership with our lab team, they wanted us to develop a custom grout, so a lime-based grout that could be pumped into the walls to provide stability. So as part of that remit, our lab team had to develop a material. They were given a set strength that they could work to, and we had to prove over a 12 to 18-month period that that material would reach a final strength that would be compatible with the wall. Also, many of the watchtowers, they'd started to notice a massive degradation within the render and the plaster coatings. So they wanted to try and return that to a historically accurate coating. And as such, we were tasked with creating a blend that included lime and hydrite, braided charcoals, wood chips, and aggregates. So this was based on mortar analysis within our lab, but we also had to research and review historical records. So the mortar had to match the physical, mechanical, and aesthetic performance that was found originally. This was a very unique one-off project, but as it was such a sensitive sort of heritage asset, all of the materials that were used within this project were actually sent off to a lab in Germany for external testing and verification. But ultimately, yeah, several hundred tons of material supplied, and we've managed to save what's considered a very, very important structure, using lime-based materials that are more appropriate for these structures. You can see the finished article. There's a brief flyover. So yeah, it's not just all UK based. Lime's used throughout the world.
Excellent.
Got my share.
Thank you, Adam. That's such a interesting, wide range of case studies there. So I appreciate we're running a couple of minutes over there. So and sorry for my technical difficulties there. That's a bit frustrating, but hopefully you've all really enjoyed today's webinar. Just to say thank you to all our Lime Group members for presenting. As I say, we do hope we'll do some more webinars very soon, get into the detail a bit more. Thank you for all our attendees for joining us, and yeah, watch this space. We'll keep an eye on our upcoming events webpage, and yeah, we'll hopefully see you again soon. Thank you very much.
Thanks, everyone. Great webinar. Thank you. Cheers.
Cheers. Thank you, guys.